Welcome to the fastest way to learn data structures and algorithms. Today, we are cracking the code for LeetCode 17, letter combinations of a phone number. This is a fundamental backtracking problem that frequently appears in top-tier tech interviews. Let us look at the challenge. We are given a string of digits from 2 to 9. Each digit maps to a set of letters, just like the buttons on an old-school telephone. Our goal is to return all possible letter combinations that the number could represent. For example, if we receive the digits 2, 3, we need to generate every combination using the letters mapped to 2 and the letters mapped to 3. Think of it like a high-security combination lock with multiple dials. Each dial represents one digit from our input. The first dial has the letters A, B, and C because it corresponds to the digit 2. The second dial has D, E, and F because it corresponds to the digit 3. To open the lock, we must try every single combination by turning each dial one position at a time. We start with A on the first dial and pair it with every letter on the second dial. Then we move to B and repeat the process. This systematic exploration ensures we do not miss a single possibility. To solve this efficiently, we use a technique called backtracking. It is like exploring a maze. We move forward as far as possible by picking one letter for each digit. When we reach the required length, we have found a valid combination. Then, we take one step back, or backtrack, to try a different letter for the previous position. We continue this process until every path has been explored. This way, we build our combinations piece by piece. Let us walk through a dry run with the digits 2, 3. Look at the screen. At the top, we have our input digits. In the middle, our recursion tree, and at the bottom, our result list. First, we look at the digit 2. It maps to the letters A, B, and C. We start our exploration by picking A. Our current path is now A. Now, we move to the next digit, 3. It maps to D, E, and F. We pick the first letter, D. Our path is now A, D. Since we have used all the digits, we add A, D to our result list. Next, we backtrack. We remove D and try the next letter for the second digit, which is E. Our path becomes A, E. We add this to the list. We backtrack again, remove E, and pick F. Our path is now A, F. Add it to the list. Now we have exhausted all letters for the second digit, so we backtrack all the way to the first digit. We move from A to B. With B as our start, we repeat the process for the second digit. We pick D to get B, D. Then E to get B, E. Then F to get B, F. Finally, we backtrack to the first digit one last time and pick C. We pair it with D, E, and F to get C, D, C, E, and C, F. We have explored every branch. Our final result is the list containing all 9 combinations. Now, let us look at the Python implementation. We start by handling the edge case. If the input is empty, we return an empty list immediately. Next, we define our phone mapping using a dictionary. This gives us quick access to the letters for each digit. The heart of our solution is the backtrack function. It takes the current index of the digit we are processing and the path we have built so far. If the length of our path matches the length of the input digits, we have a complete combination. We join the letters into a string and add it to our result list. Otherwise, we get the letters for the current digit. We loop through each letter, add it to our path, and recursively call backtrack for the next index. Crucially, after the recursive call, we pop the last letter from our path. This is the backtracking step that allows us to try the next letter in the loop. Looking at the complexity, the time complexity is O of 3 to the power of n, times 4 to the power of m. Here, n is the count of digits mapping to 3 letters, and m is the count of digits mapping to 4 letters, like 7 and 9. This is because we explore every possible combination. The space complexity is O of n, where n is the length of the input string. This space is used by the recursion stack and our current path. And that is how you master letter combinations using backtracking. If this guide helped you, do not forget to like and subscribe for more premium DSA explainers. See you in the next one.